Today we're going to show you what is the better, faster way to fine-tune your large language models. Just a reminder, all lines are muted, and today's session will be recorded, and it will be sent to you after the recording. If you have any questions, you can type in the chat. For the time being, we won't be able to answer all your questions during the session, but we will have a Q&A at the end of the session. If you are interested in use Predibase, you can visit our website and also post a link later during the presentation. We also have very active Ludwig community. You can join our Slack channel, check out the GitHub page. So today we have two speakers. We have Travis. He's a CTO and co-founder of Predibase. He will talk a little bit more about his experience later. And we also have Jeffrey. He's our ML engineer. He will talk about, give this presentation in the second half and then show us a demo. So let's get started. Travis, do you want to take over the screen?
Yeah, absolutely. All right. Yeah, thank you, Daliana. So hi, everyone. As Daliana said, I'm Travis, CTO of Predabase. Previously, have a bit of experience. Spent about 4.5 years at Uber as the tech lead for the deep learning infrastructure team there. Specifically, I spent a lot of my career thinking about how to scale the training and deployment of big deep learning systems like large language models. Still am today the lead maintainer of the Horvad project, which provides distributed training for these types of models. And also am a maintainer for the Ludwig low-code declarative machine learning project, which is a big part of the foundation of what we're building at Predabase. And with me here, we also have Jeff.
Yep. Hi, I'm Jeff. I'm a machine learning engineer at Predibase. Previous to this, I was a graduate student at Stanford working on multimodal research for medical imaging. Subsequently, I was at Google Research working on large cross-modal models, including some that were included in image search and Google Lens. And so I helped to implement these models and also run experiments across sort of undistributed training platforms.
Awesome, thank you. And I want to start this presentation today by quickly covering a brief outline of what we're going to talk about. So first, we're going to present LLMs and discuss briefly why we believe that they represent a sea change for how we think about machine learning going forward. Introduce Predibase, our platform, and what it provides in terms of offering this declarative interface that makes it really easy to get value from these types of systems for your use cases. Jeff will then, or rather, I'll actually talk a little bit about how we actually think about deploying and customizing LLMs for your tasks in the platform. And then Jeff will take over, show us a demo of some of these tools working in our environment. And then I'll close out by telling you a little bit about some of the work we're doing to compress and deploy these models to make them really available for mission critical applications in your environment. So first, to start, I want to briefly kind of frame the discussion with why LLMs, why are we talking about this today and not a year ago or 2 years ago, et cetera. And this slide comes from a presentation that Jason Wei from NYU gave recently, talking about some interesting properties of LLMs that have kind of come out in the past year. And I think this is really the best framing of it that I've seen to date, which is, if you look back a few years ago, 2018, I think even more recently, like just a couple of years ago, LLMs existed. There was GPT, GPT-2, et cetera. But beyond just doing the, generating grammatically correct text or coherent text, there really wasn't much you could do with them in terms of real world applications yet. They were still largely kind of academic, or they had some utility for fine tuning and things like that. But really people weren't using them for solving like real challenges without having to do additional training. Flash forward to today with the advent of ChatGPT, GPT-4, et cetera. Suddenly we're seeing that these large language models can do more than just generate text that looks reasonable. They can also do things that we commonly associate as like tasks that you might think of a human or an ML model performing, right? Like for example, being able to do text classification, sentiment analysis, things like that, answer questions about a corpus of data, like from Wikipedia or from your internal sources, summarize really long documents and give you kind of a high-level understanding of them. And I think even more fascinating, now we're starting to see applications where these LLMs can do some common sense reasoning, basic planning and decision making, which is where you're starting to see the advent of things like agents, agent-based systems, and even some simple mathematics. And so if you extrapolate this out to the future, it's reasonable to say, well, what are they going to be able to do, a few years from now, right? Can we start to think more about abstract reasoning or higher level planning, or using these types of systems for doing fundamental scientific research? We really don't know what the ceiling is, and I think that's part of the reason why we're so interested in exploring these possibilities now. But I think a really important thing to keep in mind when we talk about LLMs is that these systems are very general. They're meant to solve a broad range of different problems. But for most enterprises, for most people who want to use them, they're not looking for general intelligence, like having some AI friend or something like that. They're really looking for a solution to a specific problem. And so that's what we'll be talking about today, is how you can use these general systems to solve these very specialized problems. And I want to juxtapose this LLM discussion with another solution to similar types of problems, which is machine learning. And if you think about the background on machine learning and how it's kind of proliferated the tech industry in the past 10 years or so, the promise of machine learning really started with this idea of being able to take your data, derive some insights from that data, and then use those insights to perform tasks to help make your business more successful, right? And so some examples there would be, you want to derive insights about your users so that you can recommend them products, right? Or you want to derive insights about transactions so you can detect which ones are fraud and prevent them from from proceeding, right? So when you think about like what this workflow looks like in practice today, we kind of imagine it's something like this, where you might have a user, like a data scientist or machine learning engineer, who has a problem that they want to solve with machine learning. So the first thing they do is they go to their data lake or data warehouse. They do some extraction of a particular part of the data that they're interested in and create a snapshot of that data. Then they have some phase of exploratory data analysis that they're going to perform to understand the data and see like where the value might be in it. And then some period of feature engineering where they're going to try to extract certain information from, or extract signal from that data for the purpose of creating a set that can be trained on. And then spend some time iterating on training a model, evaluating on the test data, and then once they're happy, deploying it to production, to a model registry where it can be used for real-time or batch prediction. So I'm sure folks who are coming from a machine learning background are very familiar with this process. And one thing I want to do is briefly kind of frame why I believe that LLMs address some fundamental flaws with how we think about this process today. So specifically, when you look at that ML process as we do it today, and you think about where's there friction, where's there a lot of cost, I think these are a few examples of that we can dig into. So for one, lack of available training data. Today, oftentimes data engineers are required to do a lot of the ETL process of raw data into something that's analytics ready for a machine learning engineer or data scientist to consume. Compare that with machine learning with LLMs, and you see that now LLMs are able to do a lot of this ETL work themselves. They can do data chunking, indexing, synthesis directly on the data and extract out the relevant fields that can be used for training a machine learning model without needing to necessarily involve a human in the process. Similarly, a huge pain point for ML today is the lack of good ground truth labels. Oftentimes, this is the most costly part of the process, where you have to curate these labels, and oftentimes it's a big bottleneck in terms of getting something out the door as well, because it takes a lot of time to build quality labeled data sets. With LLMs, we now have the promise of being able to do zero-shot and few-shot prediction, where you can train a model or get good results from a model with just a few labeled examples, or even with no labeled examples in some cases. Cost of feature engineering, almost a very large part of the time for a data scientist is often spent trying to figure out how to encode or extract signal from raw data into something that the model can interpret without needing domain knowledge, because machine learning models don't know, what your numerical value means in the context of your business problem, right? They just know how to perform statistical analyses over the data, right? So that's a big part of the data scientist's job. But with LLMs, they actually have quite a lot of domain knowledge that exists in the background of their training weights, as well as being able to use a lot of domain knowledge that you provide them in the form of a task description or a schema for the data, and be able to use that to kind of produce an inductive bias when they're training them, when they're making their own predictions, such that there's less effort that needs to go into that from the data science side. Bespoke techniques as well once you get to modeling. So oftentimes a lot of time is spent iterating on model architectures or doing hyperparameter search. Compare that with LLMs, and actually there's so much power built into the pre-trained model that our goal is really to actually just not mess it up too much, right? We want to make sure that if we do need to fine-tune the weights or make any adjustments to its prediction process, that we keep as much of that background knowledge as we can, and we just change the minimal amount necessary to make it better at our task. And as such, there's actually very little complexity to this process. It's just a matter of finding the right parameters for the model and making sure that we make the minimal adjustment necessary to get good results. And then finally, handoff between stakeholders. Product, data eng, data science, ML engineers often are all needed to get involved to get results. Whereas with LLMs, part of the promise is that we get closer to this vision of being able to have domain experts interact directly with LLMs and derive value for their problem without needing to kind of get a whole organization involved. And so if we go back to our original workflow and then think about like how this LLM based view of the world can change things, I think it starts to look something like this, where it's less of a direct line from point A to point B and more of a little bit of a feedback loop, if you will, like a flywheel of improvement, where you have the LLM kind of sitting at the middle. So you have some operator who's able to query the model, ask questions, kind of do qualitative analyses, similar to how we think about exploratory data analysis today. And you have also the ability to connect your data as you did before, but in this case, oftentimes the way that this happens is that we create an index of our corpus that, using an embedding model, that our large language model can get access to when it's making its prediction, so that we can insert relevant context from our data into the prompt of the model that kind of tells it, hey, here's the relevant information you need to make your response. Like, what can you derive from this information? As opposed to having to necessarily train the model from scratch on the full data set. And similarly, when we think about the modeling process, instead of thinking about what model architecture am I going to use, et cetera, oftentimes it starts with creating a task description, something like what we would call a prompt for large language models, where you say, hey, here's what I want you to do, and get some results
Travis,
back.
sorry to interrupt you. So some folks mentioned they see there's a box blocking the bottom of the slide, so they cannot see the last few text. Yeah.
Is it that?
No worries. Thank you.
Sorry about that. I guess the screen sharing view was messing that up. Okay, cool. So yeah, going back to this. So yeah, we have this kind of similar to the modeling process before. You create your task description in the form of a prompt, get the model to make some predictions and evaluate those predictions. And then when we're ready to deploy, you could deploy the large language model itself for your task, or ideally you'd want to try to find a way to compress it down to just the part of the model that's good at solving that particular task and deploy that compressed form of the model. and then be able to consume it as you normally would for real-time or batch prediction, and even potentially use that model to augment the reasoning capabilities of the large language model itself. So a different approach to solving a similar sort of problem, which is how do I get predictive capabilities to solve my business problems, but now thinking about it in terms of using a large language model as the driver of this process. Okay, so that's a bit of background about what our goal is ultimately, and the kind of experience that we imagine people wanting to do when they think about interacting with LLMs for their ML tasks. And so with Predibase, what we've tried to do is build out a flow that makes it possible for you to do these things in a very straightforward and declarative way. So not having to write a bunch of bespoke code or anything like that, but rather providing like a very simple yet flexible interface that takes you through deployment of the model in your private VPC, indexing your private data set, querying the model for qualitative question answering type scenarios, customizing it to your task for quantitative machine learning problems, all the way from zero shot, few shot prediction, all the way through to fine tuning, and then finally compressing and serving for deployment. And this is really motivated by the experience of our founders, myself and my co-founder Piero in particular, of doing machine learning at Uber. So at Uber, for example, when my co-founder Piero was working on the Uber AI team, oftentimes he was tasked with multiple different ML problems at once. So for example, automated customer support. This became a model with 1,500 lines of TensorFlow, took 12 months to build and deploy. Then you need to go and do a fraud prevention model, which was 900 lines of PyTorch, took 9 months to build and deploy. Personalized offers, more lines of PyTorch, another year to get it out the door. And so what we realized was there was a lot of time being spent reinventing the wheel because you're writing code to solve these ML problems, but the code is oftentimes the same boilerplate over and over again. And what you really want is just a much more simplified way to express your task description and then have the infrastructure and the kind of artifact management and the iteration all kind of hidden away from you if it's just the same between all these different problems, right? And so that's what became the project known as Ludwig, which is open source as part of the Linux Foundation and a big part of the interface that we provide at Predabase, which is a way to kind of build these ML apps in just a few lines of code, expressed as a YAML file where you essentially say, what is the schema of the task that you're trying to do? So what are the input features, for example, some text, and then what is the thing you want to come out of the model in this case, for example, like a category, which is what is the user's intent, and then be able to provide, flexible control to give users access to different model types or different training parameters, all the way through to more advanced features like hyperparameter search. And so this is how we've approached the problem for traditional supervised learning. And we found that this approach, as Jeff will show in a bit, also applies very well to using LLMs to solve these sorts of tasks as well. And with Predibase, we're building the first declarative ML platform that takes this kernel of Ludwig and provides a managed infrastructure layer on top of it that allows you to connect directly to your data, whether it's structured data like a Snowflake or Databricks SQL, or unstructured data like an S3 file or other things. And then build a model using the Ludwig interface, so this declarative interface that we described. Track, compare, refine the models using our model repositories, which Jeff will show you in a bit. And then deploy these models and interact with them using a language that we call PQL, which provides you a SQL-like experience around analyzing the models and understanding their predictions. And all of this is fully managed and scalable, built on top of open source components like Horvath and Ray. Okay, so let's get back to our original flow. So just as a quick refresher, we want to deploy an LLM in our VPC. We want to index our internal data. We want to ask some questions about that data. And then we want to customize a model to solve a particular task, and then finally deploy that model to production. So what does this look like in Predabase? So the first thing is the deployment. And the nice thing about this is that it runs entirely in your VPC. It can be AWS or Google Cloud or Azure, or anything that runs on Kubernetes. First step is you simply say Predibase deploy your preferred LLM. So we have access to all of the open source LLMs in the Hugging Face Hub as an example here. We're using GPT J6 billion, but you can also use the Dolly from Databricks or Vicuna or any of these others. And then query the model is a very simple one-line command. So you can start to ask general questions like, what are some popular hotel chains? Second step is you'd want to connect your data to your internal corpus. So while the model might have some background knowledge about, in general, what are some popular hotel chains, let's say we're a company that, maybe manages hotels or manages a directory of hotels that folks might want to, pick when they're planning a vacation. So something you might want to do is connect a data set of these hotel reviews, which is something you can do very simply with pbase create dataset from some file containing these hotel reviews. And then next you'll want to create an index over this data set for fast context-aware retrieval, which we'll get into in a bit in terms of how that works. But essentially you would say create index given this data set, and then briefly explain what you want to do with that data set. So in this case, answer questions about these hotel reviews, and we'll make sure that the index is created in such a way that's optimized for that type of task. Next, you'll want to do go back to your qualitative Q&A, but this time using the information contained in your data set / index. So now I can ask questions over an internal corpus like, which of my hotels have poor Wi-Fi? And in this case, I'm no longer just asking the model for, in general, based on your background knowledge about the world, like what's the answer to this question, but I'm asking it for specific knowledge about my data set, right? And by passing in that index, it's now able to answer that question directly. And so the way that this works in practice is that, I feed this prompt to the model, which of my hotels have poor Wi-Fi. And then in the back end, what Predabase is doing is it's retrieving semantically similar information from this index from your corpus. Like, for example, this review says clean rooms at solid rates, blah, 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 parking was horrible, blah, blah, blah. This is such a fun, lovely hotel. And presumably, all these reviews say something about poor Wi-Fi in them or similar types of concepts to what was in the query. And therefore, it's going to help the LLM when making its decision. And the LLM finally produces a response like the hotels in your area with poor Wi-Fi are ... And that gives you, a very targeted response that's, a lot less subject to hallucination types of problems because it's coming directly from your corpus of data. So once you're able to do these sorts of qualitative analyses, I think a natural next step in this process is to say, okay, now I want to actually do something more quantitative. I want to say, give me a score for this review from the user on a scale from 1 to 5, for example. So if the review was, the hotel had slow Wi-Fi, what would you rate that review? And then be able to give it the same index to make its prediction. And it should be able to give you a response like the score of the review is 3 or whatever. And then from there, you want to scale this up even further and say, okay, maybe I have an entire data set worth of unscored reviews. And for every one of them, I want the model to go ahead and provide a rating for each of those rows in the data set. I can do this in a zero-shot way, meaning like without giving it any kind of examples to work off of. With this single command, Predibase predict, given the sample input, provide a rating, and pass in that data set, and it will provide an output data set, with a row for each one of the rows in this data set with an added prediction from the model. And then I can move up to what we call few-shot prediction, as we kind of showed before by providing the context for each example by just passing in that index once again, saying, okay, now you can have access to this index when you're doing your rating, and that index data will be inserted into the prompt to make the model's predictions. So once again, given a sample input, provide a rating. We have a sample input here, which is the hotel was nice and quiet, ... The task here is given the sample input, provide a rating. So under the hood, Predibase is once again doing the semantic retrieval to find some relevant examples to insert into the prompt. Passing that through to the LLM produces a response like the rating is 5. our predictor module is extracting out the relevant prediction from that and outputting 5 as its final response. And it's going to do that for every single row in the unscored reviews data set. And so once you want to formalize this, at this point, you're mostly doing a kind of ad hoc exploratory analysis where you're iterating on different prompts and figuring out what's working well for you. Next step is you're going to want to formalize this into an actual experiment. And so for that, it's relatively simple. You can say Predibase create model from your data set. And in this case, the only difference is instead of just passing in the prompt, you're going to actually provide a configuration file, which Jeff will show you the details about that. And similarly for FewShot, it looks very similar. Just you provide an additional index, which can either be a parameter on the command line, or you can actually provide it in your configuration directly. All right, so I'll go ahead and hand it over to Jeff to show you what this looks like in practice in Predabase.
Nice. All right, thanks, Travis. Let me quickly share my screen. I'll be sure to hide this. All right, so thanks for the handoff. Here I'm going to be doing a live demo of a lot of what Travis was saying, so you can sort of see what the development workflow is like when using Predibase. So we are going to sort of bring that example to life in the form of this hotel review rating prediction data set. So here we say, given the review text from a user, let's predict the number of stars, 1 through 5, ultimately given by the user. So here you can see the column reviews full is the title and body of the review, and the review rating is going to be some number between 1 and 5. So for the sake of this demo, I'm going to do 5 steps. The first step is going to be deploying the LLM to a private cloud environment. The second is after spinning up that LLM, quickly querying it to iterate on a zero-shot prompt. You never get your prompt right the first time, so we make it very easy to do that. The third step is going to be to take that prompt and formalize it into a Predibase experiment so that we can run batch inference on a held out test data set. The fourth step is going to be to connect this model that we've spun up into a custom training set of labeled hotel reviews. And then finally, to build on top of that zero-shot experiment that we created and to enable FewShot in-context learning for better performance. So with that in mind, let's go into my window here. First things first, I'll show you what the data looks like. So here I have it open in numbers, again, with the title and body of the review, the reviews ratings. And then also here we have this split column. And this is important because throughout, I will be showing you some numbers that are explaining accuracy, and that accuracy is going to come from this held out test data set of about 100 samples. Later on in the demo as well, I will be showing you some indexing, and that indexing will happen on the 9,000 training samples. So there's no data leakage, and we sort of simulate that effect of having labeled data that we can reference in our personal private data set to do predictions on unlabeled data. Okay, so first things first, we have to deploy our model. So it's as simple as typing a quick command. I actually have all my commands here, so you don't have to watch me type. And what this is going to do in the Predibase environment that I'm in is take the LLM that I've described here. Here it's a Vicuna model. Load it into an engine, which is our abstraction layer for compute in Predibase, and then make it available as a serving endpoint for querying and doing various forms of batch inference, or even fine-tuning and things along those lines. So, okay, that only takes a few seconds. Now that we've done that, let's see if that's worked. So here I'm going to ask it a general question that we hope the model has information about baked into its training weights, right? So here I say something generic like what makes a good hotel. And the idea is that Vicuna will respond in a way that's somewhat similar to ChatGPT, which is just sort of saying things along the lines of, a good hotel is one that is clean and has a good location. However, this isn't our task, right? if this was our task, we could use GPT-4 for this. But what we really want to do is predict hotel ratings given the body of the review. And this can be very difficult for an open source model or even the OpenAI models to do because they don't have access to that sort of semantic meaning, or there might be something going on beyond that. So for example, here, you can imagine that I am starting to try and iterate on this model, and I would like to do this task. So my first shot attempt at it is to write a query that describes the hotel. So here I have sample input, title, and body, and then I ask it directly, what is the rating of this hotel? And if I do send out this query, let's see. When I send out this query, maybe we run into some issues, right? So like I said earlier, your first prompt is almost never your last. And here, we actually don't run into any issues of misunderstanding the prompt. What we actually run into is an alignment issue where the model says, based on the information provided, it is not possible to accurately determine the rating of the hotel. Okay, that's actually a fair response in some ways, but maybe we might run into some other issues and we actually want to continue iterating. Here, after a couple of attempts, I actually was able to come up with a prompt that Vicuna was happy with. Here I put in the title and the body, and I say, given the sample input, complete this sentence by replacing the 4 X's. The review rating is of the 4 X's. Choose one value in this list. When I give the prompt to the model this time, it actually responds with something that we can use. So here we actually see it says the review rating is 3. Now, whether or not that is true remains to be seen, but what we see is that we have some value that we can then imagine using a regular expression parser to extract and use as a prediction for this particular prompt. And so we might be pretty happy with this and say, okay, I'd like to scale this operation so that I can do batch inference on a larger test set and get quantitative sort of assessment on this and not just a qualitative assessment. And so what Predibase allows you to do here is go from doing qualitative assessments, rapidly iterate on your prompt, and then when you're ready and you have something that you think could be more robust, you can transition into doing more quantitative work. And so here, what I'm actually going to do is formalize this part of the config or the query into a config. And when I do that, I will actually be writing a Ludwig config. And what that looks like is a simple YAML file that configures a particular experiment that will be run in Predabase. So here I say that my model type is a large language model and that I will be using the same model as I was using here. And that I have an input feature and an output feature. So here the input feature is going to be the reviews full column, as I described it earlier, and that we're going to use the prompt that I had written during my querying iteration. The output feature is going to be the reviews rating floor column, which I have labels for in that held out test set. And we'll actually be computing accuracy against that test set in a few moments. Crucially, we describe the vocabulary so that the model, so that we can write a parser that is able to look at the model's outputs and ensure that we have tangible predictions we can use for quantitative assessment. Now, the way that I would run this in Predabase is pbase create model. I've already uploaded the data set as a hotel reviews data set, so I would point it at that. And then I would also pass in this config. So I can just do that by copying this file path and passing it in as so. I won't actually do this because this is a demo and we don't have the time for that sort of thing. But you can see how that would be relatively straightforward to do. And as a next step, what happens is it actually will go into the Predibase platform and log an experiment that runs that exact config. So here is that config, from including a few sort of default values based on sort of what we do behind the scenes. And we can actually see the metrics here. So for zero-shot prediction on the hotel reviews data set, on that held out test set that I was describing, we get an accuracy of 37%. Now, this may not seem high, but because this is a 5-class problem that is very unbalanced, random guessing is actually around 11 to 12%. So zero-shot performance is actually not terrible. It's actually better than random, and actually 20 points better than random. So I guess the natural question is, can we do better? And the answer is yes, if you are able to incorporate your own private data. And so this is where we sort of start to diverge from the typical approach of companies that have private data but are still using OpenAI systems and cannot actually give that data to OpenAI's proprietary models. And so in order to do that, it's actually quite simple in Predibase. All we have to do is update this config. So when we update this config, one of the defaults here actually typically is for the prompt, we say something like retrieval is null. But we can modify this value to something else. And in this case, the next experiment I'm going to run is with a retrieval that is random. And so what this does is, since we have pointed it to the hotel reviews dataset, and since that dataset has a training split, what we're actually going to do is dynamically update our prompt with 3 random samples from that training set, and use those as reference examples when the model is making the prediction for this task. So here's an example rendered prompt that the model would eventually see. And here what we do is actually include labeled samples. So here we say, here's the review, here's the review floor. This is a 5-star review. And then we pass in that same sample input along with the task description. So when we run this model, which is random retrieval with a data set connected, we get this experiment back. And this experiment does a lot better. So we see here that the reviews accuracy is now 60%. And this is just from including 3 random samples from our private data set. So we already see a substantial increase from 37% to 60%. Now, I know what you are probably thinking at this point, why would we do something random? Well, this is one way to sort of communicate the baseline of just including any sort of samples in your data set. And one issue with using something random like this is that it's really high variance. Sometimes the samples are really relevant, sometimes the samples are not. And this is sort of a proxy for that case where you say, oh, well, I could label 3 samples myself, and I can hard code that into my prompt, which a lot of people do, and it is very effective. But one thing we want to emphasize is that we can use this index more intelligently. And so the final experiment that we might run for this is one where we use a semantic search. And so here I've actually replaced the retrieval section of the config with semantic type. And I've also pointed it to a secondary model, which is much smaller, on the order of tens of megabytes, like 80 megabytes. And what this will do is what Travis described in the slides, which is to read the sample input as described in the prompt, look for similar reviews in the training set, and then take those top 3 most similar reviews and place those in the prompt as the most semantically similar, and hopefully the ones with very similar ratings as well. And so then the model can lean on this, these labeled samples, these few shots, to then make its final prediction. So in that case, we actually get even better performance. So here is our model again with that semantic search, and we get 66% accuracy, which is better than random and also much lower variance because it is deterministic what samples it will pick between different test inputs. And in some experiments, we've seen that it actually can do even better as you increase K, as you give more context. But of course, at that point, you're sort of trading off the time that it takes to run on the training set or on the test set, which is what I'll show here. So in summary, we have this repository that we're starting to build up, this model repository that we're starting to build up in Predabase of experiments that show the sort of iterative development that we've taken for using and operationalizing our large language models. We started off with zero shot, which got 37%, which is what you might expect from any other large language model with no access to your data. And then we eventually got to 66%, which is almost double the performance, just by connecting our data set and doing a little bit of intelligent indexing. You'll notice that there's somewhat of a trade-off, right? Because in zero shot, our prompts were very short. We weren't using any secondary index, so we were able to get somewhat faster times. And at the very end, we were sort of doing all of this extra work. But that trade-off between duration and accuracy is one that is, up to the user to make. So we can sort of scale along with your data and help you along the way. The final thing I wanted to show you here is actually considering more real-world examples. So in this case, it was a somewhat contrived. We used k = 3 in order to keep the experiments high velocity. But we actually have 9,000 training samples. And in a lot of cases, that's enough to do fine-tuning. So when you consider fine-tuning, we can actually use the Predibase UI to allow us to do that using our large language model very simply. So the Predibase UI essentially, actually, I have it preloaded already. Looks a bit like this. So our model editor is one in which you can edit basically anything about the model architecture. For this case, our input features is where we store our large language model. And what we can do is actually just describe an auto transformer with that path, the Vicuna 13 billion model, and set trainable to true. And what that does behind the scenes is it updates the Ludwig config that we were working on earlier to train this transformer in a way that is fine-tuned on our data set, but also includes a lot of other nice features for fine-tuning a model in a performant way. So for example, we automatically set the batch size, we automatically set the learning rate and the scheduler. We use mixed precision to ensure that the training process is fast. And we do all of this work in order to make sure that you have the most performant and least costly experiment possible. We also manage your engines for you. So in this case, you're able to set the number of workers to induce data parallel training. And we also make sure that we pick the right number of GPUs to host your possibly model parallel a large language model. So then if we were in a real life setting, I would click train. I'm not going to do that now. But in summary, you can go from zero shot to fine tuning, and Predabase allows you to scale your experience along with your data. So with all of that said, I'm going to hand it back to Travis and continue the presentation.
All right, thank you, Jeff. Okay, so last thing to mention before we close and open it up to Q&A is a little about how you would productionize this in your environment. So, the important thing here to mention is that we've got a large language model to do something very powerful, which is produce really good classification results on an internal data set without having to do a lot of costly training or anything like that. We're just able to give it a handful of examples that are intelligently selected and get good results. But the latency and throughput of this is still bound by the latency and throughput of a large language model. And if you were wanting to deploy this into a production system, probably having order of second latency or something is not really what you want. You really want on the order of tens of milliseconds or something in that range, right? And so what we provide in Predabase is an ability to compress these large language models, meaning the portion, we take only the kind of part of the large language model that's specific to your task and then compress it down into a much smaller form factor by about an order of 100 to 1,000x compression into a task-specific deployable model that can be served behind a typical real-time serving endpoint with very low latency and very low cost, right? And so the commands that you would run would be simply Predibase compress this model and then deploy it. And then you're more or less off to the race and you can start consuming this for your real-time serving. And this compression process won't get into the details here because I think it's something that we'll probably want to do its own webinar or series on. But effectively, you can imagine the process being something like this, where you have your data set, with or without labels. You take that LLM, you iterate on your prompts and your indexing to get a result that you're happy with. Then you run the compression process, get a much smaller model out that is then fine-tuned to kind of emulate the results of the LLM, and then finally deploy it into production. And the benefits, like why you'd want to do this, are essentially threefold. Smaller and faster. You get these much smaller models that are much faster for inference with comparable performance. Dramatically cheaper. Serving small models in your VPC is a lot cheaper than serving an LLM or paying an LLM API provider. And you also have the privacy and security that you need for your use case. So your data is not leaving your environment. You don't have to share any data with third parties. And all of these models, from the LLMs that we deploy in your environment to the compressed model that you get at the end, they're your models. You can do what you want with them, and it's not something that's locked behind an API in Predibase. And that's essentially it. I'll go ahead and hand it over to Daliana. But thank you all so much for coming out today. Happy to take any questions.
Thanks, Travis and Jeffrey. So I was looking at the chat. I think Narv addressed most of the questions. Let's look at some recent ones. Michael asks, is there a running list of available foundational models on the platform? I assume he's asking about Predibase.
Yeah, that's a good question. We don't currently list the catalog ourselves at the moment, but what I will say is that we do integrate with the Hugging Face hub, so everything that's available there as a causal language model, you can use in Predabase as a deployed large language model.
Thanks. And what are the best storage mechanism for embeddings? How should I think about semantic search? I think previously people are asking about for feature stores. How do you think this will change the the landscape of feature stores?
Yeah, that's a good question. I think that one's maybe a little bit philosophical, but there's also, I think, like a very targeted question as well, which is, what is the how do you think about the storage layer for the index? So there are a few different options depending on the size of your data. You can do an in-memory / on-disk index, which would be like a file that's stored in S3. And that's something that is very lightweight and very cheap. And it's something that you can do by default in Predabase for smaller data sets that are on the orders of single-digit gigabytes, tens of gigabytes, things like that. Once you start to get into very large data sets, that's where it makes sense to expand out to an actual first-class vector database. And there are a number of out there in the market, like Milvus and Pinecone and things like that. And so, with Predibase, we're aiming to integrate with all of these vector databases for the retrieval, so that if you do have a particular vector database that you're using for your application, you can use that as the semantic retrieval layer, and that way, you can also use it for any of your vector database applications. And in terms of how this changes the game for feature stores, I do think that just kind of on a philosophical note, that vector DBs and feature stores are probably on a bit of a collision course, because you're probably going to want to refresh your vector database to have the most relevant embeddings, similar to how you refresh your feature store to kind of keep it fresh as well for real-time use cases. So definitely, I think that I expect that in that space, there's going to be a lot of convergence. And with Predibase, our goal at the moment is to make sure that we support all the vendors in the feature store and vector DB space, as opposed to building our own at this point in time.
Thanks, Travis. Trevor was asking, could you share Predibase price structure?
Yeah, that's something I think as engineers we're not the best equipped to answer, but we do have some sales folks who we can put you in touch with to go through those details. Yeah, unfortunately, I don't have the numbers available with me at the moment. We're still in private preview, but we are going GA very soon. And so when that happens, it should be not too long from now, we'll be able to provide very public and transparent pricing for a self-service version.
Yeah, and if you click on the left side, there's a button that says "Interested in getting started." You can request a free trial, and then I think in a month or so we're gonna open, like Travis mentioned, for GA. So you can request to use Predibase. So go to the website, and then David and the rest of the team will get in touch with you. Let's see if there have some other questions that we haven't addressed. I think Anarv has answered most of the questions. I guess before we wrap up, I want to maybe ask both of you what we're working on right now. I think you talk a little about next steps. So when people say join the Ludwig community or request a trial for Predibase, what can they expect? What are we currently working on?
Yeah, that's a great question. So coming up, we're definitely working on the 0.8 release of Ludwig, which is going to be all about these LLM features. So we're going to have the first class support for zero shot and few shot prediction. We're also going to be working on integrating that with other tools in the LLM ecosystem, like lane chain, so that you can kind of compose these together in interesting ways. And we're also specifically going to be talking more about situations where you have very large data sets and you want to use large language models to, for example, train your own custom LLM instead of using an open source one off the shelf. So maybe you want to, take your big corpus of data and build a, GPT for your specific organization. So we're going to provide a similar declarative interface for doing that, which you can then use to do the same flow for various different tasks, but on a model that's much more tailored to your corpus of data. So definitely look forward to that if this
Thanks for sharing.
To you.
Michael asks, what does real-time inference look like on Predibase? Is there an SDK or would there be a custom endpoint for models?
Yeah, maybe Jeff, you'd like to speak to that as one of the lead developers on that.
Yeah, sure thing. So the deployment story of Predabase is very simple. For a particular experiment that you've formalized, there's a one-click deployment option where you can go ahead and go to that version that we were looking at and just click deploy. At that point, then you are able to either select or will automatically select the right amount of compute resources to host your model. And at that point, there are sort of 3 ways that we're thinking about how to interact with this model. The first is in a sort of like sample payload sort of way through the UI, similar to how Hugging Face allows you to query models directly. That's sort of just like as a playground for you to understand the deployments that you have on offer. And then the other 2 ways are exactly that, right? You can send raw curl requests to that endpoint via the URL. But then the second or the third and the most preferred way to do this is through the SDK. And the reason why we say that is because the SDK supports gRPC streaming and also allows you to pass in data frames, which is a little bit easier to work with and allows you to do sort of fast analytics from within a Jupyter notebook directly. So it depends on your use case. A real-time serving could just be through curl, which is obviously platform and language agnostic. But another way to do it is through the SDK for fast analytics.
Mm-hmm. And there's another question. What are the similarities or differences of services between Predibase and Hugging Face offerings?
Yeah, so I think Dev in the comments did a good job addressing that. I think to briefly summarize, for us, like we see Hugging Face as being one of the components that we offer, like for example, for large language models and pre-trained encoders for supervised learning tasks in general. But we also provide a lot of things beyond that in terms of ML tasks, like being able to do gradient boosted trees or other non-pre-trained models, if your task is simple enough that doesn't require a big transformer or something like that. And additionally, we also have a lot of platform tools built out around Hugging Face. So Hugging Face, for example, doesn't have a big story on distributed training as a service or anything like that, or being able to do large distributed data sets efficiently and process those data sets for doing like feature transformation and things like that. So those are things that are more native to our platform. It's a bit more end to end, but definitely we see Hugging Face being like a very, very core part of the story for how we think about LLMs in particular.
Thanks, Dev and Travis. So I think we're going to wrap up. Last question. I think a lot of people also see a lot of new tools launched, new development AI. So if we want to learn more about large language models, how to use it for our own tasks, what are some resources you recommend?
Yeah, it's a tough question because the space moves so quickly right now that there's nothing very canonical at the moment. Definitely, we think that what we're doing with Ludwig and Predibase is at the forefront of thinking about LLMs for the purposes of solving specific ML tasks. But yeah, unfortunately, I don't have any great reading material to recommend. But yeah, definitely will let you folks know if I think of something.
Yeah. Jeff, do you want to add something?
Yeah, so I think Piero plugged this in a different webinar, but the lab I used to work with, actually with Piero, a few years ago, runs this SysML talk that is streamed live on YouTube. And I can drop a link if we're on for another couple of minutes, but it's a bunch of Stanford PhD students that interview, thought leaders in the space, and it's usually very, very high quality. So I recommend that to anybody. I'll see if I can drop a link quickly.
Yeah, Stanford system, ML system talks. Yeah. So I think that's all. Thank you, Travis and Jeffrey, for a great talk. And while we're still here, make sure you request a free trial and download the handout, and follow our LinkedIn account so you don't miss out on our future events. And after this, we'll send out the recording, and it will be on the event page if you registered. Thanks, everyone.
Thanks, everyone.